understand sampling distributions, you must first understand what a sample is. A sample is a part of a population. It is like a part of a whole. Values that describe a sample are called statistics. Values that describe a population are called parameters. Pause the video here to try the question on your own. Since the research center asked 50 18-year-olds, that is their sample. The population is all the 18-year-olds. 60% of the sample of 18-year-olds said they take AP classes. The sample proportion, or the statistic, is 0.6. The true proportion of 18-year-olds who take AP classes is unknown. To make a sampling distribution, just take multiple samples of the same size from the same population, and then record the averages or the proportion. This is different from a sample or population distribution because a sampling distribution graphs averages, while a sample and a population distribution graph individual data. This is our example from before, but changed slightly. Instead of taking a single sample, the research center now takes multiple samples from the same population. This population has 5,000 students, and each sample is 100 students. The research center can take multiple samples and record multiple proportions, and each proportion from each sample of size 100 can be different. Graphing all of these together creates a sampling distribution. Both the sampling distributions of proportions and of means have similarities and differences. First, both have to be simple random samples. Next, to use the standard deviation formula, although different for each one, both has to satisfy the 10% rule. The 10% rule states that the sample has to be less than 10% of the population. Also, both have conditions for normality, but the conditions for proportions and for means is different. Lastly, the mean of the proportions is equal to the population proportion, and the mean of the means is equal to the population mean. Pause the video now if you would like to try the example by yourself first. For this question, the first thing you have to figure out is if you want to use p-hat or x-bar. In this question, since it's asking about color, which is not quantitative, it's categorical. So in this case, you would use p-hat. Now that you know it's p-hat, you can use the sampling distribution formulas for p-hat to find the mean and standard deviation. Remember, when you use the standard deviation formula for sampling distributions, you must always state the 10% rule, which means that the sample has to be less than 10% of the population. Remember, for each question, you must always state the 3 conditions. The first is making sure that the question says that the sample is a simple random sample. Next, you must make sure you have the 10% rule stated, which we already did in the problem before, but here it is again. Lastly, you must check to make sure that the sampling distribution is approximately normal. For proportions, the rule is making sure that n times p is greater than or equal to 10, and n times q, or n times 1 minus p, is greater than or equal to 10. Only then can you use normal CDF to assume normality. Once you have the mean and standard deviation of the sampling distribution and you have stated the conditions, you can now use normal CDF to find the probability. The first thing you must do is write the probability statement. P-hat is greater than 0.35. That's what you want to find. Next, you use the mean and standard deviation to write the z-score. Put the z-score into normal CDF in your calculator to find the probability. In this case, since we are trying to find the probability of having a proportion greater than 0.35, you put the z-score in on the lower bound. The final answer should be around 0.1156. Lastly, variability refers to the spread of the data. When you take an individual sample, the variability is high because you have extreme values as well as mid-ranged values. However, when you take a sampling distribution, you take a bunch of averages and it gets rid of the extreme values. As your sample gets higher and higher, the values get closer and closer to your mean, and the standard deviation becomes smaller and smaller.